Hello students, we have learning your topic laws of motion, and in this video we are going towards the last point from this topic, that is nothing but the not Newton's third law of motion, very sorry, it is a law of conservation of momentum, very sorry, it is not third law of Newton's law, it is a law of conservation of momentum. See the word momentum, in which law we have seen the momentum we have seen in second law of Newton. See what is the point? The law of conservation of momentum. See what is mean by law of conservation of momentum? That is nothing but this law is similar to the law of conservation of matter. Okay, what is the statement? See, the magnitude of total final momentum is equal to the magnitude of total initial momentum. See, first of all, I want to tell you what is mean by momentum. Momentum is what? Momentum is nothing but P is equal to mv. P is nothing but we have already seen what is mean by momentum. P is a symbol for momentum, which is equal to, or momentum is the product of m and v. It is a multiplication or the product of mass and velocity is nothing but the momentum. What I tell? The momentum is nothing but it's a product of mass and velocity, which we have seen in a second law of Newton's second law of motion, and we have seen what is mean by Newton's second law of motion. Now in this lecture we are going to learn about the law of conservation of momentum. What is momentum? We have already seen. See what is statement here? The magnitude of total final momentum is equal to magnitude of total initial momentum. Why I write here Newton's third law of motion? Because the example which included in the Newton's third law of motion, which related with this law. Okay, see what is the statement for this law? When no external force acts on two interacting objects, their total momentum remains constant or it is does not change. See what will be the word here? When no external force. See, if no any kind of force which acts on two interacting objects, then what will be the said here? Their total momentum remains constant, means the total final momentum is always equal to total initial momentum. See, I will show you how it is proved. Okay, see, consider two objects. Okay, the object A, consider two objects, object A and object B. Okay, this one is the objects A. Why? Because here what is the statement? When no external force acts on two interacting objects, this is the two interacting objects. These two interacting objects, object A and object B, having masses m1 and m2. Okay, object 1, therefore I will write here m1. Here is the B, therefore I write here m2. Okay, the initial velocity of this object is nothing but, all of you know that what is the initial velocity? U is the initial velocity, therefore I write here u1 and u2. Okay, this is u1 and u2. After that, the initial momentum based on this law. See, now what will be the initial momentum? See, here is the formula for momentum, which I have already told you. Momentum is the product of masses and velocities. If the P is equal to mv, I can write here the initial momentum is m1 u1, and object, what will be the initial momentum of object B is m2 u2. Okay, after that the final momentum of these two objects, final momentum which moving with velocity v. Final momentum, how we can write here? The final velocity is nothing but the v. Therefore from these two equations I can write here the m1 v1 which is equal to m2 v2, not equal to, or the final momentum of this object. See, two interacting object, their total momentum is always constant. काय प्रूफ करायचे आपल्याला? टोटल मोमेंटम इज ऑलवेज constant. See how? If an external force apply, okay, what will be the external forces? F. Okay, if object 1 having external force F and object B having external force F1, F is equal to F2. But in Newton's second law of motion we have seen, Newton's third law of motion we have seen the two interacting objects always in the opposite direction. Okay, their magnitudes are same but their direction is always opposite. Therefore I can write here the minus F2. Okay, the F1 force apply on the object A and F2 is the force apply on the object B. From this equation I can write here, before writing next equation, see, all of you know that what is mean by the F. F is nothing but the, in a Newton's second law of motion we have seen the F is equal to m into A. Okay, F is equal to m into A. If F is equal to m into A, therefore I can write here the values for F1 and F2. That is nothing but the value for F1 is see, F is a m into A. Then what is the F1? F1 is m1 and A1. Okay, and F2 is m2 and A2. Okay, and these objects moving with a changes its motion with a time t. Okay, see, now m1 a1 is equal to m1 a1 is equal to m2 a2. From this equation, see, in this a1 and a2, a is nothing but the acceleration. All of you know that. What is the formula for acceleration? A is equal to u minus v upon t. By putting the value of a in this equation, therefore I can write here m1, what is the value of a1? u1 minus v1 upon t. Why I write here only t? Why here is not t1? Because the time required is the same. Okay, simultaneously the object interacting with itself simultaneously. Therefore I will not here t1, I write here only t. Now m2 is equal to u2 minus v2 upon t. Okay, now after that what will be the equation? T getting cancelled. See, now by multiplying the m1 into this bracket and by multiplying m2 into this bracket, m1 u1 minus m1 v1 which is equal to, here is the minus sign, here is the minus sign, minus of m2 u2, minus plus. Therefore I will write here m2 v2. Okay, after that see, the same factor will which same factor? See, m1 u1 m2 u2. Okay, m1 u1, this minus sign, when here this changes to plus sign, plus m2 u2. Okay, which is equal to this minus sign, when from this side of equal sign this will be changes to plus sign. Therefore m1 v1 plus m2 v2. This is the your law, that is nothing but the magnitude of total final momentum is equal to the magnitude of total initial momentum. This is the law for conservation of momentum. See, and it always constant. See, here is the one example. You know that very well. The firing, okay, firing bullet from a gun. At that time, when when bullet goes in a forward direction, because of that the bullet goes in a forward direction. Because of that bullet, the gun goes in a backward direction. This is known as recoil velocity, and this is nothing but the v2 velocity. Therefore, from this equation we can write here, if total final momentum is equal to total initial momentum. Okay, this is our equation. m1 u1 which is equal to, what is the equation? Sorry, m1 u1 plus m2 u2 which is equal to m1 v1 plus m2 v2 which is equal to 0. Why I write here 0? Because it is always a constant. Which constant? Total final momentum is always equal to total initial momentum. See, then now what will be the recoil velocity? Recoil velocity is nothing but the v2 final velocity. This is known as recoil velocity. Recoil velocity of a gun, and the muzzle velocity is nothing but the velocity of bullet. Okay, this v2 is equal to minus. Why I write here minus? Because of that bullet gun goes through the backward direction. Therefore, I will write here minus, and the equation becomes m1 m2 minus of m1 m2 into v1 which is equal to 0. This is known as recoil velocity. Why I will not giving here u1 and u2? Because I will write the equation for final velocity. Therefore, the equation becomes v2 is equal to minus of m1 upon m2 into v1 which is equal to, or which is this is known as equation for recoil velocity. And here is the your topic number first is finished.